Hello. Today we'll be discussing section 2.3. Topics include identities, verifying identities, examples, and more identities. So behind me written on the board are the supplement, add pi, and negative formulas from a previous video. These are just a way of finding a sign and relating it to another sign. But now with identities, we're going to try and find how we can relate trig functions to other trig functions in various ways. Examples of these include the Pythagoras identities, as well as the relationships we formed between sine and cosecant, as well as cosine and secant, and tangent and cotangent, as they are reciprocals of one another. So to fill out this list of formulas, we're going to look at the complement. Now, the complement, this angle represents the angle that if added to alpha gets us a 90-degree turn or half turn, or sorry, a quarter turn, which would be 90 degrees or pi over 2. So we're going to take this and say, okay, we have sine of pi over 2 minus alpha. That is equal to cosine of alpha. As we can imagine, cosine of pi over 2 minus alpha is sine of alpha. Tangent of pi over 2 minus alpha results in cotangent of alpha. And now, if we were to take the reciprocal of sine of pi over 2 minus alpha, we get cosecant of the same angle. So cosine, take the reciprocal, and we get secant of alpha. Similarly, for secant of pi over 2 minus alpha, we get cosecant of alpha. And cotangent of pi over 2 minus alpha, we get tangent of alpha. Now, we can utilize these identities to get other, or we can use these formulas to get other identities. And we're going to see those through the example. So the first example I want to show you is tangent of gamma plus cotangent of gamma is equal to cosecant of gamma times secant of gamma. So when it comes to these sort of formulas, there's two things that we have to do in this verification process. One, find the ugly side and make it look like the cleaner side. Now, some of these might not be easy to distinguish, but in general, if you have something that's being added or you have to distribute or something like that, that's considered like the ugly side. And then the second thing is change these into sines and cosines and solve from there. So let's do that. I'm going to rewrite these in terms of sines and cosines. So I'm going to get sine of alpha, or sine of gamma plus, or sine of gamma over cosine of gamma. That is tangent of gamma. I'm going to add that to cosine of gamma over sine of gamma. Okay, so this doesn't really help too much because I have a bunch of secants and cosecants over here. So I want to say, where am I heading? What direction am I going? Well, 1 over secant, that's 1 over sine of gamma. And secant is 1 over cosine of gamma. And when I times them together, I just have 1 all over this fraction. That's what I'm equal to. Okay, so now I know where I'm going, because I have cosine, I have sine, and here I have sine times cosine in the denominator. So now I'm like, okay, I know where I'm gonna head, so I'm going to erase this because of two things. When I'm verifying an identity, I need to get to exactly look like the other side. The other thing is that I just want to work on one side and not the other. I was doing this as for to kind of gauge a roadmap. So I'm going to keep cosecant alpha or gamma times secant gamma. So now I know where I'm going. I'm going to times this fraction by sine over sine. Sine of gamma over sine of gamma. And for this other side, or this other fraction, we're going to use cosine. I'm going to times this by cosine of gamma over cosine of gamma and have that equality be there. Now, why can I do this? Because cosine over cosine, that's essentially 1. So it's like I just times by 1. Here, it's like I times this fraction by 1. All right, well, what do we get? We get sine squared gamma all over sine of gamma times cosine of gamma plus we have cosine times cosine, so that's cosine squared gamma over sine gamma times cosine of gamma. And this is still equal to, or we want to show that this is equal to cosecant alpha secant, or cosecant gamma secant gamma. We have a like fraction, so we're going to combine them, and we get sine squared gamma plus cosine squared gamma all over sine of gamma times cosine of gamma equals cosecant gamma times secant gamma. Okay, sine squared gamma plus cosine squared gamma, that is a Pythagorean identity. It equals 1. So we have 1 over sine gamma cosine gamma. And we want to show that this is equal to cosecant gamma secant gamma. And we already worked this step out, but we know that 1 over sine, we can treat this as 1 over sine times 1 over cosine. And that gets us cosecant gamma secant gamma is equal to cosecant gamma secant gamma. And we want to put a big old check mark there. So I started with, I did not know the equivalence. I wanted to show it. And we broke it down into sines and cosines. We did a slight detour to kind of like check a roadmap on where we want to go. We then combined the fraction, found a Pythagorean identity, reduced it, put it into the terms of the identity we want to show, and therefore we have now verified this identity. So this is the process that you'll take. Now, the Pythagorean identities are going to come up a lot. They are They are used constantly. So whenever I see like a square added to another square, or 1 plus some trig identity squared, I should be thinking Pythagorean identities. As we'll see, they'll come up time and time and time again. So now let's look at another example where we use Pythagorean identities. In this case, now we're going to add some other flavors. So we have cosecant of x times the quantity of sine of negative x plus cosecant x close bracket is equal to cotangent squared x. So in this case, I would want to, again, use the left-hand side and try to solve it. So the first thing I want to do is I want to write everything in terms of sines and cosines. So we have 1 over sine of x, and we're going to times that by sine of negative x. Let's use our negative formula, and we see that sine of negative alpha equals negative sine alpha. So we're going to have a negative sine of x here. Now we're going to add, and we're going to have 1 over sine x. And we want to show that this is equal to cotangent squared x. So now we distribute the sine x. So we're going to have negative 1 because we have negative sine divided by sine. So that'd be negative 1 plus 1 over sine squared x. And we're going to show that this is equal to cotangent squared x. Now, we might look at this and say, oh, we could rewrite this as negative 1 plus cosecant squared x. That looks close to a Pythagorean identity, but the Pythagorean identity that we might be used to is 1 plus cotangent squared x equals cosecant squared x. Well, if I subtract the 1 across, I get cotangent squared x equals cosecant squared x minus 1. And that minus 1 is like negative 1 out here. So we do have this identity, and we can rewrite this as cotangent squared x equals cotangent squared x, and we're done. We verified it. Important step. You must get to here. You can't just leave it, box this answer, and put a check mark here. No, that's not enough. We have to go one more step, get to here. That shows that you know the identity that's being used. This scratch work off on the side doesn't have to be seen, but if you want to put in a justification, if you want to add in by Pythagorean's identity, you can put this in as well to your proof. Okay, so we want to simplify one expression into the other expression. Do not touch the other expression and get to that other side. For a third example, Let's use some more identities. All right, so we want to verify. So this is example 3. Secant of u plus 1 over tangent of u is equal to tangent of u over secant of u minus 1. So the first thing that we should try and do is sines and cosines. So let us first rewrite this as 1, let's write it over here, 1 over cosine of u plus 1 all over sine of u over cosine of u. Okay, well, that is an interesting look. However, can we get something useful out of this? Okay, you might think, hey, I could times top and bottom by cosine. I can kind of start playing around with this, and that's not a bad idea to try and work with that. So for instance, if I times by cosine of u over cosine of u, we get 1 plus cosine of u over sine of u. So we get another kind of interesting result, but it's not quite what we wanted here. It's a little bit kooky. So remember when I said that if we see a 1 or a minus 1 or a trig function squared, we want to try and do a Pythagorean identity. So that is what we should try and attempt to do here. But we kind of just played around with one side and we didn't see a Pythagorean identity. Well, what if we want a Pythagorean identity? Huh? Well, we can take, let's rearrange this. Let's times this side to this side and this side to this side, and we get secant of u plus 1 times secant of u minus 1 all over, and we have tangent u, and all right, let's just make this equal to tangent squared. Now, why I'm doing this is I want to try and get an idea to see, am I heading in the right direction? So here I can use FOIL or double distributive, and we get secant squared u minus 1 is equal to tangent squared u. And that is certainly true as it's Pythagorean identity. And I was able to obtain this because we have a difference or a difference of perfect squares. So I recognize that formula. So how can we mimic that here? Well, I'm going to stick to one side, and I'm going to times by the denominator on the right side. So I'm going to have secant u minus 1 times secant u plus 1 all over, and we're going to have secant u minus 1 times tangent of u. And we're wondering if this is equal to tangent of u over secant of u minus 1. Okay, well, we just showed what the top reduces to. We have this, and we got this difference of perfect squares, which is equal to tangent squared u. So I can rewrite it as tangent squared u over secant u minus 1 times tangent u. And I can cancel out one of the tangents, and I'm left with tangent u over secant of u minus 1. And that is indeed equal to tangent u over secant u minus 1. I got to my solution. Okay. So now let's try to work with some others. There's going to be a lot of examples in this video. But it's a very, very, very important skill to be able to work with a bunch of identities to get other results. Because I don't know about you, I'd rather work with sine and cosine always. Or at least as much as possible. So let's verify this one. Cosine of theta plus 1 times secant of theta minus 1 is equal to cosine of theta times tangent squared of theta. Okay? So the first thing is that we should go, okay, how can we manipulate this? What's our goal? Well, let's first just start throwing in, let's just reduce this side first because we can FOIL. And we get cosine of theta times secant of theta minus cosine of theta plus secant of theta minus 1. And we want to see what this is equal to. See if this is equal to cosine theta tangent squared theta. Okay. Well, let's rewrite this, the secants as 1 over cosine. So I'm going to rewrite this secant as 1 over cosine theta. I'm going to rewrite this secant as 1 over cosine theta. And now this is just 1. So I get 1 minus cosine of theta plus 1 over cosine of theta minus 1. And we're seeing if that's equal to cosine of theta times tangent squared theta. Now, we can tell that this positive 1 cancels with this negative 1. So we can reduce that. And I have a something times something else, or something plus something else. And here I just have 2 trig identities times by each other. So I'm going to assume that I'm probably going to have to times these together somehow. Well, how can I do that? Well, I can make this cosine squared and divide by cosine of theta. That's like I just times the top and bottom by cosine theta. Okay, what do we get? We get 1 minus cosine squared theta over cosine of theta. All right. And we want to try and get to cosine theta tangent squared theta. Okay, well, we have a 1, we have a cosine squared. We should be thinking of Pythagoras identities, and this is equal to sine. So we have sine squared theta over cosine of theta is equal to cosine, or we want to show that it's equal to cosine times tangent squared theta. All right, well, let's split one of the signs off. So we have sine of theta times sine of theta over cosine of theta. And we know that this is tangents. So we have sine of theta times tangents of theta is, we want to see if this is equal to cosine theta tangent squared theta. All right, well, we want to have a tangent squared. We have one tangent. We want to make this sign look like tangent. Well, how do we do that? Well, let's times by cosine over cosine. So I'm going to times this by cosine theta over cosine of theta. And now I have a sine divided by a cosine. So that gives us a tangent. So we can rewrite this as tangents squared theta. And that is this tangent and this sine and cosine, leaving us with the cosine in the numerator. I'm going to stick that right there. And yes, indeed, we get cosine theta tangent squared theta. And there's our verification. So if you don't see this roadmap and you get lost along the way, you can manipulate the other side. We could put this in terms of sine and cosine, simplify it, and we would have found something to this degree of sine squared over cosine. But just take one side and we want to get to the other side. Don't try and maneuver both sides, because as soon as you do that, now we don't really know where you're at. It's going to be harder to show that verification. It's easier for, it'll be easier in the long run to just start with one side and make it look exactly like the other. Come. So for another example, this will be example 4. This one, we have cosine of alpha over sine of alpha times secant of alpha is equal to, we have cosecant of alpha minus sine of alpha. Yeah. So again, we can take either side and start working with this. So the first thing that we can do is write everything in terms of sines and cosines. I know that this guy is 1 over cosine, so I can jump to this next step, but if you need to write it out, we could write down this as cosine of alpha over sine of alpha times 1 over cosine of alpha times the top and bottom by cosine, and we get cosine squared alpha over sine of alpha. Okay. And so we want to show if this is equal to cosecant of alpha minus sine of alpha. So I'm going to show you what it looks like when we kind of break the rule of working exclusively with one side now. So what I can do is I showed I could go from here to here. And now I'm going to take the other side and say, okay, cosecant of alpha minus sine of alpha, well, that is equal to 1 over sine of alpha minus sine of alpha. Well, I can times this by sine over sine to get sine squared over sine alpha, like that. And now I can combine the fraction. So I have 1 minus sine squared alpha over sine of alpha. 1 minus sine squared alpha is equal to cosine squared alpha. And we still have the sine of alpha in the bottom. And so we can show that we got the same results, and they are equal. So we have cosine alpha over sine alpha secant alpha is equal to cosecant alpha minus sine alpha. So I have to be more explicit with the expression that I'm using. So I worked with one side. I'm saying, hey, it could be equal to this. So I'm going to take this side, work it around, and I get my result. Oh. So to end off the video, we're going to do a few more formulas. We have the anti-complement formula. And to start, we have sine of pi over 2 plus theta is equal to cosine of theta. Cosine pi over 2 plus theta is equal to negative sine theta. So we can surmise that tangent pi over 2 plus theta is equal to negative cotangent of theta. And we can take the reciprocal of these identities, and we get cosecant of pi over 2 plus theta is equal to, and we get secant theta. Secant of pi over 2 plus theta is equal to negative cosecant of theta. Finally, we have cotangent of pi over 2 plus theta is equal to, and we'll have negative tangents of theta. Okay. And another set is negative complement formulas, which this set is sine of theta minus pi over 2 is equal to negative cosine of pi over 2. Cosine of theta minus pi over 2 is equal to sine of pi over 2. Tangent of theta minus pi over 2 is equal to, we get negative cotangent of theta. And I'm going to leave the rest for you guys to fill out. Your check-in learning for this video will be to complete the anti-complement formulas as well as the negative complement formulas. Write them down and submit them at the end of the week. Thank you for watching and have a great day.